In this problem, a water quality engineer is determining the max concentration of a compound that can be released into a water supply. The following data are provided. The no observed adverse effect level, NOAEL, for this compound was found to be 14.28 milligrams per kilogram day. It was assumed that the average person weighed 70 kilograms and would consume 2 liters of water per day. An uncertainty factor of 10 was applied for interspecies differences between the test animals and humans, and another uncertainty factor of 10 is applied to account for variation in human sensitivity. What should the maximum contaminant level goal, or MCLG, be for this compound in drinking water in milligrams per liter? So in this problem, the first thing we need to do is define the equations we need. If we search NOAEL in the reference manual, this will bring us to section 6.7.8 titled Risk Calculation. The reference manual provides two equations that are required for this problem. The first is the reference dose, which equals the NOAEL divided by the uncertainty factor. The second is the DWEL, or drinking water equivalent level, which is the reference dose times body weight divided by drinking water consumption, or DWC to shorten that. Next, let's write out our knowns and what we are looking for. So the problem gives us the NOAEL already, and that is going to be 14.28 milligrams per kilogram day. The body weight used in the study was given as 70 kilograms, and the drinking water consumption, we're going to shorten to DWC, is given as 2 liters per day. There are two uncertainty factors given. We can write out UF1 equals 10 and UF2 equals 10. And finally, we're being asked to find the maximum contaminant level goal, or MCLG. So what does it take to solve this problem now that we have everything we need laid out? First, we need to realize that the MCLG we are asked to solve for is actually the term DWEL in one of our equations. Next, we need to recognize that while we aren't given the reference dose, we are given the terms that comprise this variable. So let's rewrite our equation to include those terms instead. Now all we have to do is plug in our givens and solve the problem. So MCLG is going to be 14.28 milligrams per kilogram day times 70 kilograms over our first uncertainty factor of 10 times our second uncertainty factor of 10 times our drinking water consumption of 2 liters per day. And if we solve this out, first of all, we can cancel some units to determine that we're in the right units still. And we can see here that the end result is milligrams per liter, and our answer is just about 5, which we can see is one of our answers over here. So this problem is actually very easy to solve if you know a few things. 1, you need to know where your equations come from in the manual. 2, you need to recognize that the MCLG equals the DWEL. And 3, you need to understand how to manipulate the equation for reference dose to go into the equation for DWEL. And finally, you need to recognize that both uncertainty factors need to be used to account for the total uncertainty used in coming up with this standard. And that's it.